Hi, I think this is take 4 of this video. And so this is 1.4, and well, that's appropriate, right? Take 4 for 1.4. And so let's get going on it and see how we do. I push this button, almost forgot what to do and almost turned the video off. That was one of the things I did wrong. And so 1.4 is solving linear equations. And so that's the type of equation that we've been working on in 1.2 and 1.3. The strategy is to use the distributive property and combine like terms. These are the things that simplify one side of the equation, is what you're doing when you work on those. And so remember, left-hand side, right-hand side. And so here I do have distributive property. This side's all simplified, but this side's not simplified. I can distribute and make it simplified. So when I multiply here, I get negative 9a, and I multiply here, and a negative times a negative is a positive 18, right? Because that could be an add of, subtract is an add of a negative. So that's why I'm thinking of it as a negative, and then equals 0. And now I have done the distributive property. There aren't any fractions or decimals, thank goodness. And I'm going to combine like terms. But negative 9a is not like terms with 18. So no like terms to combine on the left. I only have 0 on the right, so no like terms on the right. So I'm on step 3, which is to use addition and subtraction. So I'm either going to add or subtract with the goal to get the variable on one side and the number on the other. And you can see that I don't have that going. This is the variable, this is a number, this is a number. And I want to get, so V for variable, N for number, right? And I want to get all the numbers on one side. Maybe I put them all on the right side. And I want to get all the variables. There's only one, and it's already hanging out on the left, so I'll just leave it there. So I would tell myself that I'm going to make this side have a variable. That's going to be my goal. And this side, I'm going to make the numbers. And so if that doesn't turn out, that's my goal, right? And I'm making a note of what I'm going to try. So negative 9a is a variable on the variable side. Perfect. Add 18 is a number, and I want to get it to the other side. So I'm going to either use addition or subtraction to get it to the other side. Now I want to show you that if I add 18, do you see how that's not helpful? Because 18 plus 18 is 36. And so I want to not do the same thing that's there. I want to do the opposite, right? I want to take away 18, and I like to stack, and I'm going to take away 18 here. If you're a non-stacker, then don't stack. I don't care. Doesn't matter. It's all good. So I'm going to have negative 9a equals, and then 0 take away 18, so that's negative 18 if I combine those together. And then now I have got them separated. Negative 9a is a variable term, and negative 18 is a number. So I have the variable term on one side and the number on the other, and my goal is now to isolate the variable, to get it all by itself. And you use multiplication and division to do that. So I say put your finger on the variable and divide by what you see. Works out pretty good. So I'm going to be dividing by negative 9. Both sides. So I'm going to get A equals a negative divided by a negative is a positive, and 18 divided by 9 is 2. And so my answer for A is 2. And you should always check your answer to make sure that it works. I always get people asking me, do I have to check my answer? Because I would rather not. And if you don't check your answer, if you make one small mistake, by not checking your answer, then you've turned that small mistake into a big mistake. And it's not just one small mistake. So people will tell me, I just made one little tiny boo-boo, otherwise I would have had the right answer. Well, if you didn't check, you made a big boo-boo. Not checking is a big boo-boo. And so I'm going to put the 2 in here. And use your calculator if you like, or do it with your head if you like. If I do it with my head, order of operations, this would be 6, take away 6, which is 0. Negative 3 times 0 is 0, would be great. And so we can certainly do it also on our calculator, just so that you could see. So now I've done it both ways. When you do things two ways with your calculator and with your head, you have a double chance of, if you make a mistake, finding it, right? So that if it turns out different when I do it with my calculator than I did with my head, then I know that, hey, there's a mistake. Go and see if you can find where the mistake is made. Everybody makes mistakes. Everyone does. The people that are successful are the people that have ways of checking so that they can correct their mistake. So if you want to be successful on a problem, and of course you can still make a boo-boo. I might make a boo-boo on one of these and you guys will tell me. I hope I don't, but it certainly can happen, and it's not the end of the world if it does. And so we just go on, right? We just go on and continue to do our best. And so I'm just giving you suggestions that I know are helpful to make it better. So as I go through my steps on here, I notice I have some decimals, and clearing the decimals is an optional step. And I am going to show you how to clear the decimals, and so that we can do the optional step. I would do any distributive property before I clear decimals. So I actually have distributive property here. I have no distributive property over here. So this stuff just comes down. And that's another thing that's optional, is when do you clear the decimals? And I find that it's easier to clear the decimals after you've used the distributive property. So I'm going to distribute this minus 0.3 here. So physically, I'm multiplying, and I'm going to do this in my calculator. Here, I'm multiplying negative 0.3, or you could just put in 0.3, the calculator would be fine with that, times 6. Right, that's what I'm multiplying together. And my calculator, you notice that it gave me a fraction, because this calculator thinks everything should be a fraction, because that's the best way of writing it. But because I have decimals in here, I don't want to get decimals and fractions going on, so I'm going to push S to D, and that's going to turn it into a decimal. And so that's negative 1.8, so minus 1.8. And then I'm going to multiply here. So a negative times a negative is a positive. And then I'm going to be doing 0.3 times 2x, but I only want to do, because I'm going to have 0.3, right? 0.3 times 2x. And I only want to put in my calculator 0.3 times 2. And I hope you know what 0.3 times 2 is. But if you're like, is it? Let me check. That's okay too, right? Because that builds your confidence. So if you were thinking that it was 13 over 5, no, you weren't thinking that. You were thinking S to D. If you were thinking you weren't thinking it was 2.6. And so that tells me, because I was thinking it was going to be 0.6. And that tells me, hey, I made a mistake somewhere. And I notice, oh, somehow I got in there 1.3 and not 0.3. How did that happen? I don't know. So when it come out to be something, so 3/5, I wasn't thinking S to D. Oh, yes, that's what I was thinking, 0.6. When it comes out to be something that I wasn't expecting, then I know that I've made a mistake somewhere, and that tells me, try to find it. Now I'm on clear the decimal, if you like. And I think I would like to clear the decimal. And so this is buried to the tenths. This is buried to the tenths. This is buried to the tenths, the tenths, the tenths. So coincidentally, did I forget my X on there? I sure did. Oh my goodness, I got to talking. I would have found it when I checked, but I might as well go ahead. And so everything is buried to the tenths. So that means that you multiply both sides, every single piece, by 10. So I'm going to multiply this whole equation by 10. And that means both sides, I'm going to distribute. So I'm going to multiply this side by 10 and this side by 10. So this is going to go times 10, times 10, times 10, times 10, times 10. What makes it legal is that I'm multiplying that side of the equation by 10, and I'm multiplying this side of the equation. I don't have room to write it, but times 10. And so that's what makes it legal, is that I'm doing it to both sides of the equation. Remember how that looked? A equals B. And then they told us, hey, you can multiply the whole side of the equation, 10A equals 10B. But this time, it wasn't just one piece on this side. This looks like one piece. It was two pieces. So I have to distribute it, right? And so that's kind of the story. Back to our thing. So I'm going to be multiplying every single piece by 10. So I'm going to be multiplying 10 times 0.4x and minus, and 10 times 0.1 and 10 times 0.7 and minus, and 10 times 1.8 and 10 times 0.6. So when I physically do that here, right, you can, I know it drives some people crazy not to have the leading zero. So if it's driving you crazy, put it in, right? I left it off of all three of those, and now I'm going in there and putting it in. So when I multiply 10 times 0.4, I get 4. And that's what it means to clear the decimal. When I multiply here, I get 1 equals, and when I multiply here, I get 7. And when I multiply here, I get 18. And when I multiply here, I get 6x. Now, this part right here is all I usually do in my head. I don't usually say I'm going to multiply both sides by 10 and distribute it. I usually do it in my head, if you want to know the truth. I usually say I'm going to times by 10, and then I times this by 10 and times this by 10 and start writing it down, and by 10 and start writing it down. And I see a lot of students do what I did originally, and I'm fine with that. I like that notation. I wrote it out myself originally. They write it like that, right? And tell themselves, I'm going to multiply the whole thing by 10. Why it's okay is both sides by 10, right? And they have the, and then they just go through and they distribute that. It's really easy to times it by 10, right? 0.4 times 10 is just 4. So that's it. So it's really convenient. And now I can combine like terms. I'm on, right? I cleared the decimals. I chose to do it. And now I'm on combine like terms if you have any. So I don't have like terms over here. And 7 take away 18, those are like terms. So I can do that. Let's see, 7 take away 18, is that negative 11? Is that right? And so I did it with my head, and now I'm going to verify with my calculator. I always think that's a good idea. And oh yeah, it is. So that makes me think, oh, hot dog, right? And now I notice I got variables on both sides, and I got numbers on both sides. And remember my goal in step 3, because this is as simple as this will get, and this is as simple as this will get. My goal in step 3 is to get the variable on one side and the number on the other. And you could choose whichever side, since the variable's on both sides, to put the variables. You can choose whatever side you want to put the numbers. You'll get the same answer. So typically I choose to put the variables on the left when there's choice. And some people tell me they choose to put the variables where the variable's lead coefficient will be positive, which in this case will be on the right. But I don't care. It doesn't matter at all. So I'm going to put the variables on the left, since I can't take a poll of the class and get you to vote. It could be a coin flip. Next time I'll flip a coin. Right now I have no money, so I wouldn't be able to flip a coin. So 4x is fine, it stays there, but the 1 is a number on the variable side, so I'm going to have to undo it with an add of 1. Remember, my choices are to add or subtract. And here's the number, and I'm going to line the add of 1. I have to add 1 both sides of equals, right? So 1 time on the left and 1 time on the right. Notice how add is different than multiply. Multiply, you distribute it. You do it to all. Add, you do it 1 time on the left and 1 time on the right, right? Different rules, because multiplication has the distributive property. So these are numbers, but this is a variable, and I'm going to add or subtract it. So it's going to be 1 time on the left and 1 time on the right, and I'm going to subtract 6x, and I'm going to line it up underneath its like term. so that when the dust clears, I get 0 there and minus 2x for the left. And for the right, I get negative 10. And then, long story short, I'm going to be dividing, right? Next step. This is now, the variable is on one side. Negative 2x is the variable term, and it's on one side, and the number is on the other. So I have them separated. So I move on to the next step, which is multiplication and division, right? Multiplication and division. And I'm going to use, put your finger on x and divide by what you see. So I'm going to be dividing by negative 2. And when the dust clears, I get a negative divided by a negative is a positive, and 10 divided by 2 is 5. So there's my answer, and I would want to check my answer to make sure that it works. So 0.4 times minus 0.1 equals 0.7 minus 0.3, and 6 minus 2, parentheses here. And I'm going to be putting in for x, where I put the parentheses, 5. And my plan is to use my calculator. Got my eraser dust going there. Math is not something that really works out well with pen. Math is more of a pencil sport, so that you can erase. And most people make mistakes when they do math. And so that is the reason, and I just made a mistake there, didn't I? It wasn't, because I was talking. I need to concentrate. Okay, so I'm making sure that it's exactly what I have there, 19 over 10, which is the same as 1.9. And then I want to make sure that the other side is also 1.9, so I'm going to put that whole thing in. So concentrate a little. What did I do wrong? Oh, okay. So what I did wrong was, and you see it took me a few minutes to figure out it can happen, right? And when I put this in my calculator, I put only one parenthesis here. So and I could not figure out what I had done wrong, and so I wasn't sure if I had the right answer. I wasn't sure if 5 was the right answer, so I started, trying to figure out, looking in here, trying to find where I made a mistake, and could not find a mistake. And so, but do you guys see the mistake is when I put it to check it. And so the calculator thought that was, oh, well, maybe that's not what I did wrong. Because that is, I don't know, I had something else. When I typed it in, it was saying like 57 over something. And so then I became concerned, and I thought it was because of a parenthesis. I thought I left off one of the parentheses, but when I retyped it in, it was, I don't know, it happens to everyone. Okay, so you guys, if we had been in class, would have been screaming out to me to try to help me, which would have been so lovely, because that would have made it better. Remember the problem that we had done? No, we didn't do this one. I'm sorry. We did a problem and we didn't clear the fraction in a previous video. And I told you guys to go watch the videos from the book and see about clearing the fraction. And if you had the time to do that, then you learn the clear the fraction method in the video, and it's a really good method, and I like it a lot. And so I'm going to show you how to use clearing the fraction, and so we can see how that goes. So 1/2 m minus 1/4 equals 1/12 m plus 1/6. There is no distributive property to do, but I see, oh my, there's fractions. And so what you do is you find the common denominator for all of the fractions as if you were going to get them all with the same denominator, but that's not going to be my goal. I'm going to use the common denominator for some other purpose. So the denominators, the bottoms, right, the denominators, ORS, are 2, 4, 12, and 6. And so I want to find a common denominator between all of those. So between the common denominator between 2 and 4, you can prime factor them if you want and build it, right? 2 and 4 is 2 times 2, right? And 12 is 2 times 2 times 3. And 6 is 2 times 3. So the LCD, all of these guys say that it needs to have, and you want the most, 2 2s. These guys are saying 2 2s. These guys are saying 1 2. And so we want the most of 2s, so that's 2 2s. And this guy is saying it's got to have a 3. These guys have no opinion on 3s. This guy says 1 3, so 1 3. So maybe you knew that the common denominator was going to be 3. I need 1 3, and I was going to put 2 3s down there. So maybe you knew the common denominator was going to be 12. So I'm not going to get all of the bottoms to be 12. That's not going to be my goal. I'm going to multiply every term, both sides of equal, by the common denominator. And this is how this is going to look. So it's that idea is I'm going to multiply everything by 12, the common denominator, by 12, by 12, by 12, by 12, all 4 of them. And so it's going to look like I'm going to distribute, right? I'm going to do this side by 12, and I'm going to do that side by 12. That's really the property. What you do to one side, you got to do to the other. I'm going to multiply both sides by 12. And this is going to look like when I distribute 12 times 1/2 m minus 12 times 1/4 equals 12 times 1/12 m plus 12 times 1/6. And I'm here to do this. And I know, because I picked the common denominator, that that should be a whole number. And so you could think of this as 12 over 1, and 2 goes into 12 6 times, and that'd be 6 over 1, so this is 6m. Or, your choice, you could use your calculator. What's 12 times 1/4? So you can do the math by hand, 12 over 1, right? And this is, it leaves 1 in the denominator, minus 3. And if you're saying it's a miracle that those are whole numbers, no, it's not a miracle. It's because we multiplied by the common denominator. So we planned for it to go evenly into. We picked something that 2 would go evenly into, 12. So we knew that it would totally reduce. We picked something, the common denominator, something they all evenly go into. There's another name besides the common denominator. It's the least common multiple, but it's the same character. And it is the guy that we know that all go into. And so 12 times 1/12 is 1. So that's 1m. My choice whether I just write m or 1m. And 12 times 1/6 is 2. Right? I could write that over 1, do it on my calculator. My choice. I have now made it where there are no fractions. And so step 1 was get rid of the fractions if you want, because there was no distributive property. When I did this, times 12, both sides, you see how I created distributive property. And so that's why it's in the distributive property directions. You can also live with the fraction like we did in the previous video if you liked. And that's good too. So now I'm on step 2, combine like terms, but those are not like terms, so nothing I can do. Those are not like terms, nothing I can do. So now I want to use add and subtract to get the variable on one side and the number on the other. I like when there's variable on both sides to put the variable on the left. That's my choice. I can be crazy and always put it on the left if I want. And you can be crazy and always put it on the right if you want. It doesn't matter. It's a choice. So I'm going to separate it this way, but I'm just writing you my plan. So 6m is a variable on the variable side, but 3 needs to go. And remember the choices when you're doing step 3, right, to get them separated, to get the variable on one side, the variable term on one side, and the number on the other, is to use only add or subtract. And so if you start thinking it's multiply or divide, then you're going off on a tangent. So, and so if you remember the steps, if you have it memorized, then you can solve it. Just, I mean, it really helps because when people know that it's either add or subtract, everyone can tell me it's add. Add 3 is what you need to do. I'm going to add 3 here. Those are like terms. I'm going to take away 1m here so that that's 0, and 1m here. So it is what it is. And when the dust clears, I'm going to get 5m here. And that's 0 as planned. 0 as planned. So this is only a variable on this side as planned, and 5 on that side. And then hot diggity dog, put your finger on m and divide by what you see, right? And so hot diggity dog, we're done. M is 1. Oh my gosh, my m got a double, I don't know what that, my m became a Campbell or something. I don't know. Crazy. Okay, so m is 1. I'm going to check my answer to make sure that it's right. 1/2 m minus 1/4. 1, 1. So I'm going to put this in my calculator. Just to check. So 1/2 times 1 is half, right? And so if you want to put it in, you can. And so I laugh at myself when I do something like that, when I put it in, but that's okay. And I get 1/4 on this side. And I'm hoping that the other side is also 1/4, because if it is, then that means that I haven't made a mistake. So that's 1/12 times 1 plus 1/6. I get 1/4, and it works. Okay, so lovely. And so the last one for us to do, and what happened there? I've lost somehow. Oh, you know, I was printing this. I can fix it for you guys because I haven't put it up on the internet. So I'm going to fix this for you guys. But my cat stepped on the keyboard, I remember. And I didn't realize that she got rid of my equal sign and changed the equal sign into something else. And so we're going to blame Susie on this. And bad girl, right? So it actually And I'm just going to write the problem down again. So this is problem 40. You can't have a problem that says solve and not have an equal sign. So that was what alerted me to the problem, is that lack of equal sign right there. And so, so now I fixed it. Now, if you're saying it wasn't wrong on mine, it's because I'm making this video before I've given you access to these, just coincidentally. And so I will fix it for your guys's, but I don't want to start the video again. I'm tired. I've had enough today. And so this is minus 1, right? Remember, we have had that before. And so I have to do the distributive property. So minus 6x, minus 2, minus 1, minus 8x. A negative times a negative is a positive, and 3 times 1 is 3, equals 8, a 1, right? Minus 5x, minus 1. If you think you can do this problem on your own, then pause the video and give it a try. I forgot to mention that that is a really good thing to do. And then you can run the video and see if you got the right answer. You can even fast forward if you want and see if you got the right answer. Because if you got the right answer, hot diggity dog, right? Or you can watch it and see if I do something a little bit differently than you, because there is more than one way of doing it. So now I'm going to combine like terms on the left side of the equation. So that is negative 14x. And I'm going to continue combining like terms here. So that's positive 1. And over here I have 8 take away 1 is 7 minus 5x. So I combined like terms over there as well. And now I want to get the variable on one side and the numbers on the other. So I did the distributive property. I combined like terms. And now that's as simple as that gets. And that's as simple as that gets. And so before you start adding or subtracting to both sides, you want to make it as simple as it gets on both sides. That's less chances of making a mistake. And so I'm going to put the variable, since I have it on both sides, on this side. That's what I like to do. And I'm going to put the numbers on this side. You're on the right side, on the correct side, I mean. I'm going to take away 1. Remember, add and subtract. Take away 1, like terms. I'm going to undo the subtract of 5x by adding 5x. And when the dust clears, I'll magically have variable over here and a number over there. And the number could be 0. Sometimes that happens. It's not this time, it's 6. But sometimes that happens and people tell me, oh my gosh. And then negative 14x plus 5. So negative 14 plus 5. Is that negative 9 is what I'm thinking. And I'll verify, and it is. And then I'm going to divide, right? Now I've got them separated, the variable on one side and the number on the other. The fourth step is to put your finger on x and divide by what you see. So I'm going to be dividing by negative 9. And when the dust clears and I reduce this over here, when you have that negative in the denominator, you can write it out to the side. And 3 goes in there twice, and 3 goes in there 3 times, so 2/3. And it is a really good idea to check your answer. So I'm going to check my answer. Of course, in the original, this wasn't the original. Somehow a mistake happened. I have to make a note to myself to go fix it for you guys so that it won't be a mistake for yours. But, and so when I put this in here, so this is negative of, and then 6 parenthesis plus 2, into parenthesis minus, and then 8 parenthesis for the x minus 3, and then that's equals. So on this side, I'm going to be putting in here negative 2/3 and negative 2/3. And so I want to show you something, a way that when it's more complicated like this, I know I got those negative 2/3 kind of blurry and kind of small, but that you can do. It's just kind of helpful. you put in negative 2/3 downstairs, and that's the last answer that I had. And then I can put in, instead of typing in that whole thing, since I have it in these two places, I can just put answer. So I can go minus, and then 6, and then parentheses answer at the bottom. And that's the last answer, which was 2/3, negative 2/3, plus 2, minus, and that's just a little bit of a savings in this one of work. So answer, because 2/3, right? It's the last answer, minus 3. So on this side, I'm getting 31 over 3. And I'm going to see what I get on the other side. So on the other side, I have 8 minus 5 and parentheses, right? Plus 1. And I want in here negative 2/3. Now, if I go and do answer again, well, 31 over 3 is the last answer, and I want it to be negative 2/3 if I want to do the answer trick again. And so then I would have to put it in again, negative 2/3, right? And so that now I can do the answer trick if I like, or I could type it in on that side. It's not as bad on that side because it's only one time that I would have to put it in. So your choice. Always have choices, right? Plus 1, and I hope, so tired that I hope beyond hope that it is right, and it is. They worked. Okay. So you need to make sure that when you're doing your problems that you check your answer, and if it doesn't work out, that you fix it. And it might be like the last one where I was making a mistake when I checked it. And so, but once I figured out where figured out where the mistake was, and so anyway, so you want to always check. Okay. This video is getting long, but it's only got one more thing to do, and then I'll be able to go have dinner, and I'll be done with videos for a little bit. So I'm really happy about that. So some linear equations have one solution, and we've been solving those. And some have no solution, and we haven't seen one like that. And some have every real number as a solution, and we haven't seen one like that. So this is problem 14 out of your book, and problem 14 out of your book is one that has one solution, and the type is a conditional. And I don't care if you know that that's the name of it. That's not a big deal. And a conditional one is true for some values of x and false for others. So when we find the value of x, that's the value of x it'll be true for. And so I know that I already told you that I know that it has one solution, but normally you wouldn't know if it has one solution or none. So I'm going to use the distributive property to solve this. So 1/3 times 6x, right? And I'm really physically doing 1/3 of 6. Well, 1/3 of 6 is 2x. And 1/3, right, of 3, 1/3 of 3 is 1. And you can use your calculator. And on the other side, I had 1. On the other side, I had 1. So I want to get the variable on one side and the numbers on the other. But the variable is only hanging out on the right. So I'm going to go ahead and put the variables on the right. That's the only time I choose to put the variables on the right, when they're already there. And I'm going to put the numbers on the other side. And so 2x is where I want it, 1 is where I want it, but this 1 right here is not in the correct spot. So I'm going to take away 1, and when I do, I get 0, and I get 2x. And this is where a lot of times people will say there's no solution because they got 0, but 0 is a number. And I was wanting to have a number over there, and I have a number. So there's nothing wrong. Everything's cool. Everything's great. Put your finger on x because you got the number on one side. You got the variable on the other. So you do your multiplication division. Put your finger on x and divide by what you see. So I'm going to be dividing by 2. And when the dust clears, 0 divided by 2 is 0. So we're going to have, I'm out of room, but 0 equals x. When I look in the back of the book, they just put 0 as the answer because they were asking you, what is x? And then what is x? Well, x is 0. And so the answer is there's one solution, and it's x equals 0. And that's cool. And I'll allow you to check that. If you want to, you can check it with your head right here. You put in 0 there, then we have 1/3 of 3, because 0 plus 3. And 1/3 of 3 is 1. So here, on this one's a contradiction, and it's never true. And right now, from looking at it, I can't tell that that's the case. But when we start solving it, then you'll notice that that's the case. So I would be don't know what the story is until I solve it, right? But I've advertised what the story is going to be just for the learning purposes here. So minus 3x, right? Have to use the distributive property, solving normally, plus 6, right? Not suspecting anything is amiss. So plus 4x. So then I would be on combined like terms. And so when I add those together, I get 4x plus 6 equals negative 20 plus 4x. And this is where you start to see, oh, this can't be true, because both sides of the equation have 4x on them, right? They have balancing 4x's. But 6 is not equal to negative 20. So no matter what x is, right, that would balance out. But 6 is not equal to 20. So what some people say is keep solving, right, if you don't believe me. So if I keep solving, I'm going to put the variable over here and the number over here. So I would subtract 6, just to do my normal way, right? And I would subtract 4x, do my normal way. And on this side, this is 0, and this is 0, so I get 0. And there's the problem, is that I said that I wanted the variable on that side, and I'm not getting a variable, I'm getting the number. And then getting a number. And then on this side, I also have a number, negative 26. And those two numbers are not equal to one another. That's what makes it no solution. And so, anyway, so that's the story. Right now, your book says no solution. And then later in the book, they say that the symbol for no solution is this symbol. You may not make your zeros like that, because there is a difference between 0 and no solution. And so if someone taught you to make your zeros like that, then you need to change the way you make your zeros for this class. This symbol actually means something different in chemistry than it means in math. And when you take a chemistry class, you'll have to learn about that. So you can write the word no solution if you like. Notice that I do not have the line through it, and if I put the line through my 0 here, then it would be wrong. So on here, my answer was 0, and it would be wrong for me to write this, because I would be saying no solution is what I would be saying. Actually, I would be mixing two things, and this is not even the way to write no solution. So it's not right to write that. So just be careful on that. So you can write no solution if you want the word, or you can use the symbol for no solution. That means there is no value for x that makes it true. This one's called an identity, and an identity is true for all replacements of in this case, y, and I got x's here, but in this case, I have y's going on, don't I? So if you start solving this, no distributive property, combine like terms, 4y minus 3y is y, plus 7, and I have on the other side y plus 7. And you notice the sides are exactly the same. Whenever you get to a place where the sides are exactly the same, that means that there's all real numbers. Every value for y is true. We'll make the left side equal the right side. If y is 1, then the left and the right will both be 8. If y is 0, then the left and the right will both be 7. They'll both be equal. If y is 57, then the both sides will be, I think, 64, right? And so all values, even if you make an icky fraction, half, right? Then there'll be 7.5, both sides. And so this is all real numbers. And the symbol for all real numbers is this symbol. This is how it's made with print, typing, and this is how most people make it when they're handwriting, is they make the R and then they make a line through it like that, through the R, and that means all real numbers for the solution. If you're looking for more examples on these, there's more in the book. If you're thinking to yourself, oh my gosh, the video got really long. I know it did. I'm sorry about that. This section was a little bit longer. But remember, you can do it in chunks. And I'm telling you at the end when I should be telling you at the beginning. So in the future, if a video gets too long, pause it. Do it in chunks. Okay, talk to you later. I'll see you, my friends.